The we are in live, sir. You can.
Good evening and welcome to this live class of our NPTEL course, Foundations on Virtual Reality. So in the last few weeks, you have been looking at the several topics, basics of the virtual reality, basically geometry, building the geometry, lights and optics. So far, no, there was no major questions from the participants of the course. Therefore, what I thought is, in today's class, we will introduce what are the major challenges in a virtual reality. Right? So now, knowing the challenges ahead will keep you focused on a topic of your interest. Right? I'm going to list in today's class some of the research topics. Of course, there are a lot of challenges as remaining, but I'm going to list only some of the challenges today. And then if there are specific topics, we will take it up and then discuss. I'm going to share my screen. I hope the screen is visible. I'm going to get into the full screen mode. Okay. So we are going to look at now the research challenges in all this now, the entire course, right? Some of them we are going to look at it. Particularly, I'm going to list this now 10 research challenges. We don't have to worry about now. Later, we'll now look at it. The first research challenge I wanted to discuss today is the definition. We all looked at the definitions of the virtual reality in the earlier classes, right? So Professor Steve Lavalley has now nicely defined this. Nicely defined this. I'm going to minimize it. Yes, the definition of AR VR, right? So there are specific words which we wanted to highlight it, and particularly we need to induce the specific behavior and organism, not necessarily only the human being, and we are now using this artificial sensory system. It is not in natural sensory systems, artificial sensory systems, and then stimulated while the organism has little or no awareness of the interference. This is the most widely now used definition. If you search in Google for the definitions of the virtual reality, you will get hundreds of definitions. You will find that it is not as good as this definition what we are now learning in this particular course. Okay? It is as wide as possible, correct? And at the same time, it is now including all the components of the AR/VR. If you look at the major components, major elements of the virtual reality, we are looking at 4 elements. Right? There is a virtual world, both AR, VR, MR, XR. Each one has different levels of the virtual world. And there is an immersion component. It can be either fully or partial. And there is a sensory feedback, whether it has a vision alone or auditory a combination, haptics, gustatory, smell, or a combination of all those things. And then, now, most importantly, the interactivity. So either from the user can interact with the virtual world, and the virtual worlds also can interact with the user, or it can be either personal or social. Correct. So this is, I hope it is giving you the wide maybe we can say it's a combination of all the VR systems available as of now. What you can do is, as an exercise, if you can find a way to improve this definitions in your homework, we'll be very happy to look at it. Right? So can you expand this definition? You can use ChatGPT or now all the kinds of the AI, and then find out how this as now definition can be improved. And if you find out a way to improve, you can justify also. Right? So this is a challenge we are actually making it. So you can use it ChatGPT in all your courses. We are not asking you to be away from the ChatGPT or any other AI engines. Predominantly use it, but now use it wisely. So now don't take the content of the AI as it is. You have to now interpret it. You have to be very cautious whether it is making sense or not. That is more important. So the thinking process, how you are thinking, and is what now we are actually looking at it. Okay, so this is just an exercise for you to now see whether now the AI system is now better than this particular now definitions it can suggest. Right? This is the first challenge. And the second challenge is going to be now it, based on our already introduced in the last live class, where I mentioned that XR is a highly interdisciplinary. It is not just one field alone can make up the XR. In fact, among all the engineering, I would say XR is the most interdisciplinary now system because it brings in so much of complexity, particularly now because because the focus is on the human perception that we looked at it last time. Human perception. The focus is on human. The AR, VR, and MR, it is made for the human being, right? When they are using the system, we should be able to understand how the human perception is actually now working, right? That is the focus, correct? Therefore, or now the psychophysics becomes now very important among all the things. Psychophysics is the study of now how do we measure the human perception. So it is now the hardware and then software at all. We can make a lot of innovations once you understand the human perception. So in this particular course, we will introduce a little bit of the psychophysics, and I run a separate course on psychophysics in IIT Madras, and we will see whether we can and introduce in the NPTEL course as well. So to reduce the complexity of the AR VR, and then given the so much of complex the complex nature or many interdisciplinary nature of the AR VR, we thought now we will assume that AR VR is standing on two pillars. One is the immersion, another is the interaction. Most of the AR VR courses, they focus on immersion. They even in our course we are going to talk about the immersion. How do we improve the immersion? What are the different factors which leads to the immersion? Right. So what are the different techniques now used for improving the immersion? We are going to see. That is only the 50%. The other pillar, a very important pillar, equally important pillar, is the interaction. How do we improve the interaction? How do we make interacting with the virtual world as natural as possible, as natural as real interaction? most of the XR systems, they focus only on the XR immersion, but not on the interaction. What you're going to learn in this course is that now the interaction also is equally important, and therefore, how do we improve the interaction is again, we are going to look at it, and that is one of the biggest challenges, right? So I'm also going to quickly touch upon what are the other type of the definitions of the virtual reality or other dimensions of the virtual reality definitions we are looking at it, right? So when we start with now real environment, this side, the other side, there's a virtual environment. In between, mixing both the real and the virtual environment, we can come up with either the augmented reality or augmented virtuality. In the augmented reality, we are looking at the real environment to the through the AR glasses, and then we are adding a little bit of virtuality. Okay, so a little bit of what you call virtual elements. There is the augmented reality. The reality is augmented. Whereas in the augmented virtuality, we have this mostly virtual world, and a little bit of reality is augmented over here. That is the augmented virtuality. Virtual world is actually augmented, right? So little bit more, what we can say is that, so here is the real environment, and here is the virtual, completely virtual environment. This is completely virtual. This is a completely now real, and in between we have the now augmented reality and augmented virtuality, and this is the real virtuality. This is a completely virtual reality. So this side we have this ubiquitous virtuality. Ubiquitous virtuality is that we are talking about the now embedding things. So we are now embedding the computers in a system, or in a computers in a day-to-day activities, elements. Now that is the ubiquitous virtuality. Whereas here pervasive is all about mobile phones, laptops. These are all coming with the pervasive components. So you can see that the embeddedness of the everyday objects, right? That is becoming the real virtuality, and then the pervasive virtuality is bringing the total total reality. Okay? And this is another way of looking at it. So we have the physical reality, we have the virtual reality, augmented reality, and augmented virtuality, and then together both augmented reality and the mixed reality. Virtual reality together maybe now mixed reality, and XR is another term you will come to know. All those things together, all these AR, physical reality, virtual reality, and the mixed reality together is what the extended reality. And along with this haptics, olfaction, and gustation, together we can call it as a experiential technologies or spatial computing. Okay. That is another term you will be coming across in most of the literatures. So one good example you've all seen is the virtual reality flight simulators. You are already aware of it. Now virtual reality mobile phones, which we are going to use in our the entire course. Now this is a one wall projection. Now virtual reality, it is a completely virtual. It doesn't give you the full immersion, but it is now one wall, some partial immersion it is giving you. This is the immersed desk. Again, it's an example of the VR. So you can see that it is not just the headset alone is giving you the virtual reality. It's called the virtual reality. There are many different types of the virtual reality is available. This is a most popular virtual reality is the binocular HMD, which is now as of now all popular. Right? There is a monocular and a virtual reality also is there, not necessarily binocular. And then smart glasses are all possible. And then VR cave is there. This is a projection wall. All the sites of the cube or environment room. It's all projected with a virtual reality environments, and then without the headset, the user inside the room is feeling completely immersed. Right, but only the thing is this now cave system is now highly expensive, and therefore only few corporation and companies can afford it, and not everybody can experience this, right? So looking at the AR VR in another dimension, like transportation, coming from the transportation. Suppose if the x-axis is it can be either local or remote, and then y-axis will say it's artificiality, either the physical or synthetic. Then we can put all this now augmented reality and virtual reality, physical reality, and telepresence in this particular graph, right? So local is completely physical reality. This is is physical as well as local, and then augmented reality is local, but it is has some synthetic, whereas uh, 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 the virtual reality is remote as well as it is completely synthetic, right? Whereas telepresence, it is now physical, but actually it's a remote. I should be able to now touch and feel the physical objects remotely. That is the telepresence. There's also another term you'll be very often coming through. So I want you to be now familiar as well. Right? So if you look at the VR technologies, we can classify them according to how it is as immersive. If you look at only the visual, so we can start with the very low immersion and to go to the high immersion, right? So the HMD, fully binocular HMDs, they offer the highest immersion because it occludes it's from the external environment, and therefore it gives you the highest immersion. Cave, which we saw, all the 4 wall or 6 wall projections, they all can be now just below the HMD. IMAX theater can give you the lesser than the cave, and 3D projection screens that can give you the again some kind of immersion, but not very much. Desktop 3D monitors are there, and then desktop monitors gives you very low immersion, and then finally the lowest immersion can be our handheld devices like your mobile phone, right? Handheld devices keeping in the hand gives you the low immersion, whereas the handheld device putting into the Google Cardboard, then it gives you the HMD kind of immersion, right? So you can see that the immersion we go from lower to higher. Right? So there are other displays as well, but this also gives you the immersion. For example, now uh, uh, visual display, oral display, haptic display, thermal display, smell display. Every senses can have the display, and particularly here we are talking about this displays either can be world fixed or user body fixed. Here is the haptic display where the haptic is actually rested on the ground. Therefore, it is a world fixer. And here is another hand gloves which gives you the touch feedback. This is now user or body fixed. There's a lot of differences we are going to see. The differences is between this world fixed and body fixed displays, not only haptics but also the other things when we talk about the haptic displays now towards the end of this course, right? And here is a taxonomy of the virtual reality. This is based on the literature, again based on the immersion. Based on the immersion, researchers have come up with a taxonomy. For example, virtual reality can be classified into very basic or enhanced. Very basic one can be either hand-based or monitor-based. Enhanced one will be either partially immersive or fully immersive. Fully immersive, either it can be room-based or binocular HMD-based. This is what now we'll be mostly using it. If it is room-based, either it can be a cave or now vehicle simulation. The partial immersive can be either monocular head-based or immersed disk, which we saw, or single or no, double wall or multiple wall projections. This is based on the immersion, how well it is immersive is. The same classifications we can actually do based on the interaction as well, right? Interaction as well looks same, but slightly it is going to be different. For example, uh, 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 here, if you look at the fully immersive of VR, or here is the binocular head-based HMD, which we call it as binocular. So this is a fully no the interaction wise, it is the HMD is classified under the fully immersive, whereas all this room based and the vehicle and cave based will be part of the now partial immersive. Because as far as the interaction is concerned, now only binocular gives you the fully immersive, whereas now even the room based or cave based, it is actually partially immersive. Yeah, let me skip this content. So based on the interaction also, we can actually, from the low interaction to high interaction, we can look at the VR technologies. Head tracking is the minimum interaction we are looking at in the virtual reality. Right? Then keyboard, mouse, joystick, game controller, hand tracking, haptic gloves, treadmill, full haptic suit, BMI, brain machine interfaces, and then user to user interaction is the another high level interactions. So we are looking at now the VR technologies or XR technologies based on the now low interaction to high interaction. One user in a XR should be able to interact fully with the other user, is the most interactive now system which we can think about. Right? This is apart from the speech interactions, or this is apart from any other interactions possible, right? Maybe using the gazes or the eye, that can be different. So based on the HMD also, we can actually look at how different VR technologies are there, from the low immersion to high immersion. Monocular HMD, now mobile devices as now give you the next level of immersion, curved display, and then foveated rendering. Using the eyes, we can actually now we can track the eye and then render high resolution on the display wherever we are looking at it. Other display, the peripheral areas, we can actually render lesser resolution. That is the foveated rendering. When we are looking at the rendering, we will look at it. In the next few classes, we also are going to look at the eye physiology. While looking at the eye physiology, you will look at the fovea as well as peripheral vision and the differences, anatomy, and the perceptual differences, all those things we are going to read. Projection into the retina. There are some displays which actually directly projected onto the display instead of projected onto the retina instead of display. That is the projection into the display. So when we look at the display chapter, which is towards the end of the course, we'll talk about it. HMD with a tactile feedback, and then so that is the probably towards the high immersion. So even in the cave, we can look at the low immersion to high immersion, depending about whether all the walls are fully projected or not. So the most immersive is all the 6 walls, including the top as well as the bottom wall. If it is all projected, then it is the highly immersive. Otherwise, 5 wall, 4 wall, 3 wall, 2 wall. It's all now progressively it is increasing the immersion. For example, here is one movie which I wish I could show you. This is projected onto the screen, right? Sorry, projected onto the sphere, spherical projection. Okay, so do you call this as a highly immersive? Okay, that is a question. So the the there is a sphere, static sphere, but from 4 or 5 different projectors outside, it's all projecting onto the sphere. So when do you call this as a highly immersive or low immersive? That is a question. Probably now you can take a look at this particular video, which I'm going to now share it with you. Okay. So the feature of VR, again, we looked at it as whether it is a ubiquitous as computing or the pervasive computing. Pervasive computing is where the embedding is come to a picture. Your printer has the computing element into it. It can take the print request from multiple computers without even getting connected to it. There's a computing element over there. Yeah, that's a computing element over there. So this is the x-axis is the what is the level of mobility? Right? So if when the mobility is very low, this is the pervasive computing. This is the y-axis is the embeddedness, level of embeddedness. That's right. When the mobility is very less and the embeddedness are also very less, that's a traditional computing, all our desktops and all I think. When the level of mobility is very less, at the same time embeddedness is more, like a printer, right? That's a pervasive computing. Whereas the mobility is very high, but embeddedness very less. That is the mobile computing. Whereas mobility is more, and the embeddedness also is more. That is a ubiquitous computing. Right? Yes. Okay. So just let me. So yeah, we should be able to let me quickly go through it. Okay. So looking at the interaction, again, we should be able to interact not only with the world, but also the world should be able to interact with us. That is what now we call it as a natural interaction. Again, interaction, there is a lot of taxonomy the literature has given, whether it's the avatar appearances or autonomous automatic actions, body languages, coordination, control and coordinations, gestures, language-based communication, object-based interactions, physical contact, and the world modifications. These are the different interactions possible, right? And using the hands, these are the different grasp type is possible, whether it is a power grip or intermediate grip or precision grip. I hold my pen in a precision grip. Whereas now, if I hold a driller, that is the power grip. So power grip means there are certain gestures we do. Precision means we use few fingers for precision grip, whereas the intermediates are there. All this interaction we should be able to support it in the virtual reality if the task demands, right? That is what in a level of interactions what we are looking at it, right? And then then there is also social interactions, right? How do we communicate socially, right? So illusions of social communications. What are the implications in the virtual reality? So what are the principles of the social communications? We are talking about the one-to-many or transformed social interaction. These are all, again, the challenges the researchers are still working on it, right? So the standard communication model, basically, the Shannon's communication model, which is actually very famous right from the 1950s, right? that doesn't include the human being in the loop, right? It is for the machines to interact. How the language is now, how the input is coded and encoded, and then how it is channel capacity, all those is are calculated based on the entropy of the system, right? So Shannon communication is very well studied model, but it doesn't include the human being, right? When we are talking about this communication, social communication, we need to include the human being as well, not only the network system, but also the human being, right? That is one challenge, right? So the human, when they are included, then we are talking about the audio, video, and gestures and the smiles and then empathy between this human that has to be captured. Okay. So then, when we are talking about the social interactions, then the avatars, how the avatars is actually now has effect on the perception in the teleportations or whatever it is, right? Whether we can the avatars are either can be anonymous avatar or or you can choose different avatars, and then different avatars has an effect on the way you interact with the virtual world. That is called the Proteus effect. If you look at what is the Proteus effect. So depending upon the race, gender, age, and physical characteristics, the way you interact with the world is also different. If you choose a particular avatar, you tend to act like the particular avatar. All the physical characteristics or the race and gender, it's all changing. It's what now the Proteus effect is. Similarly, if you suppose choose animal as a avatar, then now your characteristics is changing, right? So how much effect is actually carried forward? What is the limit of it? That we do not know. The researchers are still looking at it. Okay? So the challenge of the presence. Okay. Before we talk about it, is in the immersion we have this. We have this in the social VR. We are talking about two terminologies: presence and co-presence. Okay. So how well you are immersed, how well you feel presence, that is the subject of research in virtual reality. What factors add to the immersion and the presence? Immersions and presence are related terms. There are subtle differences which we are going to see later. And when you feel the another subject also co-presence with you, right? The sense of presence, right? Sense of being at a place and perceived realism, that is we are going to deep dive into the sense of presence. Immersion is about the technology to induce the presence, whereas the sense of presence is the perceived realism. It is not a technology. So that way these both terms are actually related. Telepresence may not involve the other human beings at all. Co-presence involve other beings. These are the difference in these terminologies. The challenge of the presence is that what is the minimum required realism, right? So if you tend to create the virtual environment and to the accuracy, the most accuracy is possible, we will end up entire life actually. That is not needed. What is the minimum required realism for the challenges presence? That is a big challenge, and that's the topic of research now. Right? So, in this sense, in the social VR, the sense, one important terminology will come to the embodiment. Right? Just like a sense of presence and sense of co-presence, there is a sense of embodiment as well. How well you own the avatar, what is shown in the virtual reality, right? That is the sense of embodiment. That's a personification and incarnation, right? Immersion is a technology to introduce persons, which we have seen it, whereas sense of embodiment is how well you own the body. In fact, one of our collaborators, which we, some of the papers we are going to say later, Professor Mel Slater from Barcelona University. He is a leader as far as the sense of embodiment is concerned. He talks about changing the avatar of male to female, female to male, or maybe third gender or animal. So to make you feel how now the other gender is actually now perceiving or the issues they are going through, right? The sense of embodiment, there is a lot of factors that induces the sense of embodiment, which we are going to now look at it. So the sense of embodiment is particularly look at three different factors: self-location, sense of agency or control, sense of body ownership. We will see in the later classes. But still, this is a now active subject of research. How the sense of embodiment is induced? What are the more factors? How easily or minimum required and factors that needs to be that is needed to induce the embodiment. Okay, so yes. In the social VR again, we are talking about either the one-to-one communication or one-to-many communication. There are video conferencing tools. The symmetry relation, if n is less than 10, or family or friends, it's a complementary relation. If more than 10, and if, for example, in a classroom or the meetings, right? So complementary, where we have one is a superior, whereas the symmetry means we are talking about the equal status. In the family and friends, we are talking about the equal status, whereas in the complementary, one is the superior, whereas the classroom teacher is bossing around or whatever it is. In a meeting, there is one presenter who is giving the presentation. So how do we bring this symmetrical relation or the complementary relation in a virtual reality? And we can take advantage of this virtual reality technologies to enhance or enhance the some of the advantages of social gathering, right? And there are verbal cues are there, non-verbal cues are there, haptic interactions are there. So how do we make all those things in a social VR? Is the possibilities here? For example, the teacher one, if is looking at one in a physical classroom, so teacher can look at only one candidate at a time. Let us say eye contact with only one student. Whereas in a VR, in a social interaction, the teacher can have a eye contact with all the students simultaneously. Similarly, if possible, the teacher in a physical classroom can have only interaction with only one student, say handshake or a high five, right? So whereas in a social VR, the teacher can handshake with all the participants simultaneously. That should be now possible, right? That is a feature which is actually coming up. In fact, now we are going to experiment this concept in the later part of the class. As one of our scholars is actually making a prototype where uh, you can simultaneously interact with many persons, right? And in a social VR, it has now many applications. There are many applications coming up, particularly for the cyber crime is lately coming up. So in a metaverse kind of places, where is it's a implementation of the social VR, right? How do we ensure the safety of certain and group, say particularly women, the safety in a in a metaverse for women is one of the hot topics now, and Oculus is actually looking at it. Right, it has come up with certain and solutions, but it is not sufficient. There are researchers now looking at it how to come up with how to improve the safety. Right, who is responsible to maintain the social what do you call rules, right? Which country jurisdiction comes into picture, right? So because metaverse involves a lot of countries, it is across the borders. So which country will have the jurisdictions over the metaverse? That is a challenge now, which is still being discussed. It is not that all the legal communities are all now discussing. There is a language barrier, right? So there's a diversity in the languages of the culture and the social structure, right? So how are we going to overcome? These are the challenges we are going to talk about. Okay. So and then other interfaces like we are talking about now sound interfaces. There are now a lot of challenges in this now audio interfaces, right? Audio interfaces. Here is the now recently Apple has come up with a patent on virtual speakers, right? So the virtual speakers, you will hear the sound from now somewhere where there is no speaker. That's the virtual speaker concept they have come up with. They have implemented it. So you can search for sound bars, right? There are recently there are markets, Apple sound bars are there, so you can actually look at it. And Sony has come up with the 360 degree reality audio. It again and using the virtual speaker concepts, and there is a Dolby sound and Dolby Atmos as that is the one of the standards which is actually now coming up to produce the 360 degree audio. There is a lot of research going on to create the surround 360 degree surround and sound, right? The later classes we are going to talk about what are the research challenges as far as the creating the 360 interaction. And this is a smell, right? As far as the smell is concerned, how many smells we can create in a virtual reality, right? So one of the well-known movie called Lemus, which our music director A.R. Rahman has created, where he has as of now 4 smells he has created, and there is an effort going on to increase the number of smells to 8 and 16 and so forth. Right? This is a standing leaning interfaces. So if you can search for something called enjoyment, where this is all Michael Jackson actually has shown in some 20 or 30 years ago in one of the performances where he completely leaned against the gravity, right? So that gives you a stunning performance in front of the all his fans. But how do we create this kind of leaning interfaces is again a challenge, and this maybe can be used for locomotions. How do we make it locomote in the virtual reality environment? How do we now move and do a lot of activities? Again, there are many locomotion supporting devices in the market, but again, there's a lot of research is actually needed. This is one of the challenges. How do we enable the VR users to locomote from one places to another place and still interact with the virtual reality? These are the many consumer locomotions. And finally, now I'm going to now discuss about some of the updates on the VR headset. This is the just last week release. This is a project Mohan from Samsung. They have created the very thin HMDs, VR headsets, right? So here are usually the optics which you are learning, right? That is very, very important as far as the VR is concerned. And this optics is making it bulky because as it has to be, if you use a regular lens, then the display images has to be now projected onto the infinite plane, right? So that is taking some space and therefore it is bulky. But what the users need is the very thin glass-like HMDs. Glass-like HMDs with a lens, it is not possible, right? That is why a lot of research is needed in order to make it very, very thin glass-like structures. Samsung has been making these glasses in India, and that project is called the Mohan, right? They are going to release it in the next 6 months. And now I want you to keep yourself curious on this particular project because it is being done in India. Okay? I wanted you to look at what is the now particularly optics they are using. Right. So I would like you to explore and then learn a little bit of it. So the challenge is that here the optics. What are the different optics is possible? We are going to learn in the later classes. So Meta also is making the thin HMDs, right? So again, the latest Meta, they are going to again release it very shortly, right? It's all in the research labs. Right. And another challenge is that the virtual reality headset, usually Oculus, if you look at it, it's a FOV, field of view, it's about 120 or 110, even sometimes lesser as well. Earlier, now they have come up with a headset with 180 field of view, which is a big challenge. And that is again, it is in the research lab. They are not at release. It is going to be released very shortly. The higher the field of view, the costlier the headset is, and the more immersion is. We are going to learn what are the different factors which leads to the better immersion, better presence. Correct. So field of view is one of the important parameters, and there are headset. How do we make headsets which gives you the bigger field of view? While we are studying about the eye physiology, you will understand now what is the field of view which is needed. Ideal headset, what is the field of view needed? Then let us look at what is the different headset and what is the field of view they are offering it. How much is the gap between what is already now in the headset and how much is needed? That you can the gap can be filled then. Similarly, resolutions, right? There are many headsets. Recent headsets are increasing the number of resolutions. When you are looking at when you are studying the eye physiology, you are going to look at what is the resolution needed for any VR display, right? And I'm going to ask you to now find out what is the current resolutions that displays are offering it. What is the ideal headset requirement? What is the gap? How long we will take up to reduce the gap between what is already available and what is needed. Right? So different headsets are offering. As of now, the best headset which offers the most headset resolution is the Virgio, and the latest is the Apple Vision Pro. right? Virgio also, they have different versions of it, which has different resolutions. And the first one started with our simplest Oculus back decade 2, right? And all those headsets can be compared in many different parameters, right? So this is the VR headsets. There are now Sony spatial reality display. Spatial reality display, I want you to now take a look at now how Sony is actually bringing the 3D effect in a desktop monitors. Okay. There are YouTube videos. Actually, I'm going to share it with you. You can take a look at it, right? And there are cave environments and commercially available multi-view 3D monitors and the stereoscopic 3D monitors. So this can be compared in multiple parameters, and then how our VR headsets is faring with the latest spatial reality displays and things like that. So spatial reality displays is need not be actually we don't have to wear the headset, but still you get to see the immersive 3D environments. There are some crazy 3D displays I wanted to show you. Is it pause? Can I pause it and then go to the? So here is a 3D display.
This building is collapsing, but it's not what you think, because it's actually a 3D billboard in China that looks so realistic, it literally tricks your brain. And is this cool or terrifying? Because just look at how the advanced LED screens create the craziest visuals like sharks and even robots jumping right out at you. But this tiger is the best one because watch how it terrifies everyone. This building is
okay. You saw this 3D display. These are 3D billboards, right? So what is the technology behind? Right? So we are going to learn it, and basically it is a standard display, but your visual perception is actually there are illusions are used in order to give you the 3D depth information, which we will see in the later classes, right? This is the Sony's spatial reality display.
So I wanted to tell you more about this spatial reality display. So this is a glasses-free 3D display. So you can build assets in Unity or Unreal in 3D and see them in 3D on this display without needing glasses or a head-mounted display or anything. So we see a lot of applications in retail for demonstrating virtual inventory or in digital signage for a more immersive experience. We have CAD designers, artists, NFT creators using this 3D display. So there's a ton of different applications. Game developers are using this as a way to confirm their 3D models of characters and creatures before they build them into the game. So there's so many ways that you can use this. And this is using eye tracking technology. So this is really unique in the industry. And this gives a much higher picture quality. So you're seeing all of the pixels from this 4K screen in your eyes as a 3D image. So it's extremely immersive.
So Sony is actually, aggressively, marketing this. So
So
we are
for
going to
more
see,
information,
we are going to see later how what is the technology behind and this one, and then uh, in glass. Okay. Okay. Sure. Ah, yeah. So this is where now to make a better display, we need to understand the human perception. We need to understand the sensation manipulation and then interactions. Only when we measure it, we can now make a science of it. Only when we make a science of it, we can make an engineering of it, and therefore the technology of it. Therefore, measuring perception is very important. The next week, you are going to learn about the visual perception. After the eye physiology, visual physiology, you are going to learn the visual perception. That's a very important week. I would like you to focus on it and then correlate with the latest happening in this particular field, right? And that is where now we are bringing in this new concept of perception engineering or perception algebra or perception physiology, right? And then where the algebra, where different stimuli, S1, S2, S3, these all different stimuli that all combined, differentiated or integrated and in the cognitive field, right? And then the response is actually generated. How it's all done, that is a new math we need to develop it. That's again the big challenge. The future direction is that the psychophysics of the multimodal illusion. That's a big research. As of now, the state of the art is psychophysics of single sensory illusion is what is known. But the psychophysics of multisensory illusion is still not there. That's a big challenge. Sensory level as well as the motor level, psychophysics, now experimental and theoretical psychophysics, virtual reality without the hardware. Is it possible? Now, that's the big challenge which you are going to face. And AI, along with the perception engineering, that is going to be the future, representing the now with the ontologies. Ontologies are the different classifications, knowledge-based systems, like for machine interpretability. It is the future. That is where now AI will have the eyes and ears and touch and sensory aspects. Along with the AI, it's going to put the human at the center, and then therefore it is going to have larger impact than the AI itself. And then finally, I'm going to stop with this ultimate XR. This is a big challenge. What do we mean by ultimate XR, right? So ultimate XR is something that nothing beyond it, nothing beyond is in the sense, can we have a XR effect without any of this gadgets, without the headset, without the display, without the microphone, or without the speakers, without the haptic devices, without small devices or anything, right? So that is where the challenge is. For this to happen, we need to have a science of XR developed. We need to have an engineering and technology of it. Human understanding of human perception is a core of it. I hope at the end of this course, you will have some idea about how to build the ultimate XR. We will talk in some details towards the end of this course. Right? We will go through the challenges in detail again at the end, and but just to give you an idea that there are several challenges you have to you have to keep it in your mind while going through the week lectures. I'll stop here. I'll take if there are some questions. let me read some of the questions. Growing plants in controlled environment is also applicable by this definition of VR. Is a question. So the question is again, growing plants in a controlled environment, is it called a now VR? Okay. So look at the definition of the VR. So the VR has to be organism. Here you are saying plant is an organism, right? Can the plant have a virtual reality? That is what your question is, right? So in a controlled environment, you see the virtual environment or controlled environment is what you're giving us a virtual reality, right? Is it interactive? I told you, VR should have a interaction as well. Just having the virtual reality, virtual environment is not qualifying it as a VR, right? It should be interactive. In what way the plant environment is interactive? Interactive to the plant, right? It is not interactive. Therefore, it is not virtual reality, I would say. I hope I have answered this question. Okay. Anything else? If there are no more questions, we will meet next week with more questions. What is mixed reality and its example? How is it different from holograms? Okay. So I hope augmented reality and virtual reality is very clear. So mixed reality is the now different people have different definitions. Now Apple has a different definition of mixed reality. Now Google has a different definition of mixed reality, and Meta so forth, right? So augmented reality, you are looking at it through the AR glasses. You are looking at the real environment, a little bit of virtual environment. You are putting that. The reality is augmented. In a virtual reality, there is no real environment at all. In a mixed reality, there is the augmented reality as well as the mixed reality. There is actually fully enclosed environment, completely enclosed environment. But now you still see a small reality which is coming over here through the cameras attached to the virtual reality headset. And then that real environment, actually it is embedded with virtual environments, and therefore it is modified a little bit, right? Or the real instruments are brought into the virtual reality, and then that gives you a feeling of now you are interacting with the real environment, right? So that is the virtual reality, right? So virtual mixed reality is which has characteristic of both augmented reality as well as the virtual reality. That is the idea. Okay. Is it immersion if we grow a summer plant during winter by giving it controlled environment and focusing the plant into flowering? Okay. See, what is the organism over here? The plant is the organism. Does it interact with the virtual environments? Virtual environment is a controlled environment we are talking about, right? It is not interacting. Therefore, it is not at all virtual reality, is what now I would say. Can you say whether the dream is a virtual reality or not? We all see the dreams, right? Can you see whether it is actually a colorful dream or black and white dream? And do you have a control over the dream? And therefore, is it a virtual reality? Can it be classified as a virtual reality? So to me, dream is not interactive at all. I don't have any control over it. right? It goes just like a movie. It just goes as on by itself. Therefore, it is not virtual reality because it is not interactive. Right? So the next question is that I was thinking about how in dreams we completely accept even impossible things as real, because the part of the brain that questions reality is less active. But in virtual reality, no matter how real it looks, we still have that awareness that we are in the headset. Do you think understanding how the brain switches off that now self-checking in the dreams could help now VR feel truly real? And maybe with the things like brain stimulation combined with neuroscience and cognitive design could get closer to that level of immersion. So realism is not at all needed for immersion, right? So for different aspect of it, different level of realism is needed, correct? So if you think now we have to achieve the completely realistic, only then we will feel the immersion, not necessarily, right? So and therefore the answers to your question is that we don't have to go to the brain stimulation and extent and to induce the immersion effect. There are certain elements of the virtual reality which induces immersion. That is what this course we are going to talk about it. What are the factors other than the realism of the virtual environment that is going to induce the immersion, right? So by the end of this course, I hope you will understand, right? Okay. So the next one is that, yeah, 1960 movie with a great script, acting, lighting, and camera work can be immersive in the brain. Can a VR movie with a mediocre plot, acting, lighting, etc. also have same immersion? Basically, the operative word is interactive. Okay. Yeah, good question. Um, uh, reading a book is actually very immersive, right? We don't need HMD for getting immersed into a book, right? Do we call that as a virtual reality? Again, look at the definitions of virtual reality. Imagine this now, the two pillar concept of the virtual reality. Immersion is very important. At the same time, interaction also is important. Without the interaction, immersion is not useful. Without immersion, interaction alone is not useful. Therefore, both the pillars are necessary for the building. Therefore, in this case, no, in this case, no, yeah, movie is not at all VR, right? Because it is not interactive. It is highly immersive, but it is not interactive, right? VR movie is interactive. At the same time, it is immersive. Therefore, it is considered as no VR. Okay, the next question is that does this VR devices affect on the eye of the users? Uh, so one of the objectives of this course is that at the end of this course, we will understand what are the health effects of the virtual reality. It is not just the eyes, it is even the psychology of the user may be affected. Every technology has a effect on the health. It has a positive effect as well as a negative effect. So we need to see whether the positive effects has is more than the negative effect. Right? Everything is a double-edged sword. You need to be very prudently use that technology. Okay. The next question is how do we adjust VR lenses if the power of the eyes affects? Yes. So to if you have the headset and if you are wearing the glasses, power glasses, you don't have to take out the glasses. Either you can use the headset over the power glasses, or you can take out the glasses and then put on the virtual reality headset. Both will have the same effect. Again, you are going to learn why this both have the same effect. Maybe the coming week you will learn when you are learning about the lenses, diopter, and other effects of the lenses which you are going to learn. So the answer to your question is that we don't have to adjust the lenses if the power of the eyes has any defects. Because the optics in the virtual reality headset is adjusted in such a way that it is it is focusing on the infinite plane horizon. Okay. Are there any more questions? Should I purchase a headset to effectively work on the virtual reality and making animations? We don't need to buy the headset for understanding the concepts and doing the homework and quizzes for this particular course. Right? That we made it very clear in the last few classes. If you're still interested in doing your project, your personal project, please go ahead and buy it and then please use it. Nobody is going to stop you. But for this course, you don't need to buy it. All the assignments and quizzes is going to be on a Google Cardboard. Okay, so we will stop here. Thank you for patient listening. And then until we see you next week, please stay safe. See you next week. Bye. Thank you.